Hey everyone, you're not going to want to miss this episode of the AI Show where we're going to learn how you can revolutionize image search with cognitive vector search. Let's jump in. Today we are joined by Varsha. Welcome. Why don't you tell us a little bit about who you are and what you do?
Thanks, Cassie. Hey everyone, I'm Varsha Pratsarthi, product manager on Azure AI, and I focus on computer vision technologies. I'm happy to be here, excited to share more about image retrieval using vector search.
Cool. We did a show recently showing how to use cognitive search for vectors and focused on text. But this time we're going to be looking at images. So, can you tell us a little bit more about how image search works within cognitive search?
Yeah. So image search or image retrieval systems have traditionally used features like tags, labels. These are extracted from images or even descriptions to compare images and rank them by similarity. So keyword search is the most basic form of this information retrieval approach, where the search engine looks for the exact match of a keyword entered by the user and returns images that contain the exact sort of keyword stored as content labels or image tags. And keyword search, as you can imagine, relies heavily on users' ability to input specific search terms. So let's take an example. I love hiking. I'm in Pacific Northwest. I'm trying to find images of like hiking with friends in the rain, right? Again, hiking as a word or term is not used globally, right? It could be bushwalking in like places like Australia or trekking in places like Asia. So if the images aren't tagged with hiking specifically, you wouldn't be able to find those images. Um, Now, contrast that with vector search, right? On the other hand, where you have semantic similarities between the user search or the context within the search query, and that is being compared with contents present in the image. So, even if you search for something like trekking or hiking or bushwalking, all of those search queries would lead you to the same sort of images that you're looking for that are relevant to the search query. So, in this case, for vector search, both image and text is converted into vectors and stored in the same high dimensional vector space. I'll show you a demo in a minute and how Florence enables the vector search within images. It enables both text to image as well as image to image vector search.
Okay, cool. So that really tells me a lot about how it can kind of enhance maybe some of the like current features I might have to solve, searching for keywords within images. Now I'm going to be able to get a much better response because I'm going to be able to have a more semantically correct search using, you said, the Florence model. Can you tell me more about what the Florence model is?
Yes, great question. So, as we know, with by now, like with ChatGPT, DALI, BERT, the industry is definitely moving towards large foundation model, and
Mhm.
Microsoft has also invested and trained a large foundation model for vision and language specific tasks. The code name being Project Florence. It's a transformer-based model trained on massive amounts of data, billions of text-image pairs using self supervision. Now, why is Florence important, right? So traditionally, to train a computer vision model, you'd collect a relevant training data set, label it for specific tasks. So if you're training for object detection or tag classification, you train a model, label the data for that specific task. And for each task, you train an independent model. And whereas for foundation model, which is Florence, you train one base model using massive amounts of data, and in this case, we're using both image and text. So it's a multimodal base model. And then you have adaptation models that help you fine tune this base model for individual tasks like classification, tagging, image captioning, and so on. It also does enable newer tasks like image retrieval or visual questioning and answering, like visual chat. So it's a multimodal base model that enables all of these new user experiences and scenarios.
Okay, so I understand now what the Florence model is and the power and capabilities that it's bringing to this task. Where can people learn more about the Florence model?
So we released Florence earlier this year. So there are research papers published, and you can find out more through that, understand more about how the model was trained, how the model performs on benchmarks. So you can find out more with those published papers.
And then let's see how this works. Can you show me how this works within the cognitive search functionality?
So let me start with Vision Studio experience. This is a no-code interactive experience where people can try out all the Vision features that are available within Vision AI. So I'm specifically going into searching photos with image retrieval. So here you can put in a natural language sentence as a form of text query and find images that you're looking for within your data set. So before I jump into the demo, I do want to make it clear that these sample images don't have any metadata associated with it, so no content labels or tags associated with them. And we've provided a couple of these image data sets that people can try and test the Florence vector search experience with. So let me quickly go through maybe one or two of these examples. So I'm picking manufacturing in this case. So these are the images that you see below are the images present in the data set. There are about 250 of these images. Now let's go search for a query. So I'm picking one of the pre-curated ones. So let's take a look at boxes on a conveyor belt, for example. So you see images that pop up. Again, none of these images have any metadata associated with it, so it's just pure vector search. And you can see more images as you go through the slider. This is all the images that are relevant to the query that I've typed in here. Now let's try another one, people looking at tablets together. Again, you see these images that are popping up. Again, I can increase and see more of these relevant images pop up. You could also try your own custom query. So, and I can change this to people looking at information on a tablet together, wearing maybe safety hats. Let's try that. Now you're seeing images with people wearing safety hats looking at the information together on their tablets. Now, as you can imagine, these are complex queries that we're looking at, and Florence does a great job with vectorization and finding the relevant images in this case.
So what's happening here is we have these data sets and the Florence models running and giving the results based on the text prompt that you're giving it. And then that's how it's able to get these. There's no metadata, there's no text associated with it. It's all with the power of Florence.
Exactly.
Very cool.
So let me go to a concept page. This is a publicly available page within Azure Cognitive Services. So let me just go through what's happening with the Vision Studio, right? So we saw a bunch of photos within the photo dataset or the photo library. You vectorize those images using Vectorize Image API. Same thing with vectorized text. You take the user query, which is in the text form, vectorize that. Now that you have vectors in the same space, multidimensional space, you store it in a vector database. And then you perform something called a similarity function. And here I'm using a cosine similarity, but you could essentially use any distance function to measure the similarity between the two vectors and find the top n or the top 10, 5, whatever the image vectors that you're looking for, and map these vectors back to the images and provide that as results. So that's essentially the concept of how the image retrieval system with vector search works. I do want to go back real quick on the studio aspect. So we just saw the curated data sets and sample data sets with the text query. You could also try with your own images signing into Azure account. You can bring in 500 images, quickly create a POC and see how Florence works with your data set. With that, this does limit the demo is limited to 500 images. So if you want to create your own API dataset, I would highly recommend to get started with Cognitive Search, which makes it easy to set up a vector database, create a search index, and have that end-to-end search system set up.
That's so cool. I think showing how it worked is really helpful because it seems very magical when you just see it work, right? But then when you break down step by steps how we're taking images and words and putting them into vector space, and just if they're closer together, they're more similar using the cosine
Yeah.
similarity. And that's how you find it. I feel like every time I see that, it still is just so brilliant and simple at the same time. And it really kind of puts together how they're able to work so well.
Yeah, exactly. So now let's jump into how vector search works with cognitive search, specifically for images. So you might have seen in the previous session that Liam shared, we're using the same data set and sharing the same index. So in this case, it's a recipe of a food and ingredients present in those foods. So text is associated with it. But in this particular demo, I'm only using the images within the document set. So it's only images of food and like recipes associated with it. With that, I'll get started with what I'm trying to do on this Python notebook. So I'm importing the libraries that I need to set the demo up. I'm also importing the index from Azure, Cognitive Search, the search index that was already set up. I have a JSON configuration with all the passwords and service endpoints. Here, in this case, you would need two accounts, one for Azure Cognitive Search and one for Azure Computer Vision. Both of these accounts have been set up, so I'm just creating those connection and endpoints. So let me run that.
And what is the computer vision service used for with is that part you need to use that as part of the cognitive search or how are those two working together?
Yeah, great question. So, cognitive search today allows you to bring in vectors, whether it's like OpenAI vectors through ADA embeddings or Florence vectors through Vision embeddings. For all of these services, you would have to first figure out where to generate these vectors before bringing it to cognitive search. So, for images, we're using Azure Computer Vision APIs to generate those vectors for images.
Okay, makes sense.
Awesome. So here I'm defining two functions that we just spoke about, generating embeddings for images for the image set. And here I have around 2,300 images of food and sort of the recipe data set. I'm using the image retrieval API, in this case, vectorize image API, to generate vectors for the image data set. Doing the same for text and the text query using the same version, which is another key point. Different versions of the model does have slight variations in the way vectors are presented, and we do not recommend different versions to be used together. So yeah,
So you want to make sure that you're using that same model also when you create your index and vectorize your images. So you want
exactly.
to okay,
Yeah. So a vector that is, or the model that you're using for vectorizing text and vectorizing images need to be the same model in the same vector space, which is where you can do the right comparison and find out the semantically sort of similar images for that text query.
makes sense.
Awesome. So moving on, I'm just running this code to vectorize images and text. So that ran successfully. Now for the fun part. So here I'm going to show both text to image search as well as image to image search. So let's try something like fish tacos. I'm taking the top 5 images and you'll see the results at the bottom. So you're seeing both scores. So I'm displaying the score here and the image ID. And again, image ID is important for us to give the image back and sort of map it to the relevant document this particular image is present in. Yeah,
So we just to kind of go over the call that was made. So this is the Python API or SDK, and we're calling the search client. So we have the fish taco text, and
yeah,
we are sending that in. We're generating the vector for that text, and then we're sending it into the index that we've already created, and then it's going to return the image that is most similar.
exactly.
Okay.
Exactly. So, so fish tacos again, an easy one, and you can also see the score of the distance function. So these are Florence similarity scores that we're seeing here. So let me just scroll down. So these are relevant images that we're seeing with fish tacos. They all look great. So let's try something a little more complicated. So garlic shrimp with green onion, right? Let's see what that would generate. Let's try something else. Maybe ramen with boiled eggs on the side, which is my standard order. Let's see if that works.
Every time we do this data set, it makes me hungry. Like I just had lunch, still hungry now. Ooh, that looks amazing.
Right.
Yeah.
So clearly it's doing a great job with image search. And you could also type in something with like, I don't know, let's try that. Florence also does a good job of just like figuring out what the user is asking for. Like the term doesn't need to be specific, doesn't need to be correct with respect to the spelling errors. And as you can see, it's giving me results for shrimp pasta or spaghetti pasta with shrimp.
So, what type of use cases are you seeing customers or people interested in using these features for?
Yeah, definitely a lot in digital asset management. So there's a huge need to be able to reuse the assets that were created by either marketing agencies or by like people licensing data. Again, there's a huge cost nowadays to have like data licensing done. So you want to be able to utilize whatever data that you're buying or licensing to the utmost capability. So discovery and search and like aspect of being able to find what you're looking for as instantly as possible are all features that we're seeing where our customers are using it for. The other neat thing that we're also seeing people use it for is more like product recommendation or product
Mm,
cataloging, where they're not only using image search as like the primary pure vector search, but also augmenting it with metadata around it. So you can think of like PCs having different versions of like different OSs or laptops with specific product IDs, or it could even be clothes with specific product IDs. So you're augmenting the vector search with metadata search, and we call that hybrid search within the cognitive vector search pipeline. So you could do something like that as well, where you could have flexibility of doing both.
that's so cool. I could see it on the similarity search. Like, I want something that looks like this. Or maybe I'm on like a food ordering app and taking pictures of my
Exactly.
food finally makes sense because I find a meal that I had and I want to order something like
Yeah.
that. I mean, that'd be kind of interesting too, just the different ways that you could use images that you have in order to find something similar.
Exactly. Like I look at a ton of Pinterest boards and I'm like, okay, where do I find this piece of clothing? Doesn't exist today, but
Sure.
you could soon have that as an image input to one of these websites and get like the product that you're looking for.
That's so cool.
Awesome. So let's jump into, so we saw text to vector. Now let's check out image to image vector search. So here I'm pulling in a picture of lasagna. So let's try what it returns.
So now we're taking an image instead of text, embedding that and sending that as the query.
Exactly. So we're looking at this is the picture that I'm using to send it to the query for vector search. And here are the results that I'm getting back. Again, with pretty high confidence. Again, possibilities with image to image search are endless. We've seen even within like chat experiences or bot experiences, people send like products looking for like similar products that they're looking for if something is out of stock, or if they have a very specific like snapshot that they've taken, don't remember where it is from or what brand it is of, they could just easily search with the image and find relevant links for those products.
So, what different languages does this support? I see we've been using English. What other languages can we vectorize?
Yeah, it's a great question again. So right now we support English with the embeddings, but we do have a multilingual model that supports more than 100 different languages,
Oh,
and
wow.
that's coming out soon. So stay tuned for that.
Okay, so that's not out yet, but it's coming.
Yes.
Awesome. And then the other question I have is I see that we're using Python and we're using the Cognitive Search SDK. What other languages are supported for this, programming languages?
Yeah. So currently, the computer vision API is endpoints, REST endpoints that you could use. SDK in Python, C++, C Sharp. Those are all coming, so should be available in a few months. As well as on cognitive search, you already have SDKs available in popular languages like Python and C++.
Great. And then you're using Azure data sources. Does my data need to be in Azure, or what different data sources are supported?
Great question again. So it doesn't need to be in Azure. Definitely, it helps within cognitive search to have Azure data or Azure blob storage. But you can also bring in your storage, whether it's local or storage that is in other services, and plug it into Azure Cognitive Search.
Great. So you have the flexibility to plug in your data source and have it indexed.
Exactly.
Um, Another question I have around indexing your own data is I know there's tooling within it. We kind of talked about that on the last episode, so everyone should go check that out for getting those indexes set up. Um, how frequently should someone be re-indexing their data? Is that kind of by a basis of what they're trying to do, how often their data changes, or how do people make that decision about when they need to create the new index that will overwrite the existing one?
A great question again. So again, if the data set hasn't changed, if you're dealing with like the same 5,000 images, you don't need to reindex ever, unless you want to switch over to a different model or you're trying something else that is not available in the current indexed model. Um, but as you bring in more images or more text, you would have to do an update to the index. So it wouldn't be re-indexing for all of the images, but just for the new images to update, and there's a function called sort of recrawl. You recrawl with all the new data that has been added to the data set and only index those to add to the existing index.
And that's something I could have on a schedule as well, right? So I don't have to necessarily manually trigger that. I could say, I know my data is going to be changing every day. I want to reindex every night or something like that.
For sure, yeah. You could use the API endpoints for like a specific timeline every week, every day, or whatever the schedule is. Or you could also set up a function that would say, do a crawl, and if there is any new data present, then crawl that and update the index.
Fantastic. So it sounds like there is lots of functionality already for being able to get the data in and being able to leverage this amazing powers.
Yeah.
Okay, so we saw some really cool demos. We learned a lot about how we can start leveraging images in cognitive search. Where can people go to learn more?
Yeah, so you could get started. The easiest ways to get started with the blog announcement post that we just saw, as well as Vision Studio, where you can try out these experiences and create an easy POC. Or you could go into the Python, the GitHub repo that we have, where you could use that code to set up the image retrieval systems for your search index.
Great. So I'm showing those links below. They're also in the description for this video, so you can go check those out and you can get started with the image search capabilities in Azure Cognitive Search. Thank you so much for hanging out with us today.